Okay, guys. So we will go through the questions together over here. Okay, so let's look at it. So number one, okay, they are asking us about what type of alcohol is 2-methyl butan 2-ol. Okay, so butan 2-ol, so it's going to be 4 carbon. Okay, 4 carbon. And then position number 2, there's methyl, and then position number 2, there's OH. So you can see here, this is going to be a tertiary alcohol. Okay, so this is going to be a tertiary. So I'll just put down tertiary. Now, what type of alcohol is pentane 2-ol? Okay, pentane 2-ol is going to be, you just do the same thing. Okay, 5 carbon. And then at position number 2, you have OH. So you have one R group and another R group. So this is going to be secondary alcohol. Now, compare how vigorous the reaction with Na with both of the alcohols in question 1 and question 2. So if you have more R groups, okay, the OH bond will be stronger. So we have tertiary will be less vigorous, secondary will be more vigorous. So I'll just say pentane 2-ol, okay, is more vigorous compared to 2-methyl butan 2-ol. So far, okay, Nathan?
Yes, sir.
Okay, now next, write the balance equation for the combustion of pentane 2-ol. Okay, if you want to make it faster, okay, you remember the general formula is CnH2n plus 1 OH. That is for alcohol. So pentane is going to be 5. Okay, so C5 H double plus 1 11 OH. You can just write down like that. Okay. So plus with oxygen, okay, they are going to give us carbon dioxide and water. Okay, you have 5 carbon. I put 5 carbon over there. Hydrogen, they are 12. Okay, so I put 6 over there. And I have a total of how many oxygen on my right hand side? I have 16. But here, I think the most common mistake is students tends to forget about the O in the alcohol. Okay, so if you want to put there, I want 16. Okay, so one of the oxygen is there, so I need another 15 oxygen only, so I just put 15 over 2. Okay, so when we put it over here, it's going to be, you can times everything by 2, so you get 2C5H11OH plus 15O2 to give you 10 CO2 plus 12 H2O. So that will be your final answer. Now, for number 5, okay, ethanol can react with HCl, okay, and this HCl, it can be prepared in situ and heated under reflux. Okay, what is the mechanism of the reaction above? So the mechanism is nucleophilic substitution. So do remember, any reaction involving alcohol, not any, okay, depends on the type, okay. So generally, if you have alcohol or halogenoalkane, they will undergo nucleophilic substitution. Okay, but you see, there are certain situations that you do not use nucleophilic substitution. For example, if you are using halogenoalkane with sodium hydroxide in ethanol, for example, so that is going to be elimination reaction. And let's say we are going to have some other reaction like oxidation of alcohol, dehydration of alcohol. All these are not nucleophilic substitution. Okay, so it depends. Okay, it depends. Okay, now what is meant by in situ? In the same reaction vessel. Next, okay, how HCl is prepared in situ. So it is going to be heated. Okay, what is going to be heated? You are going to use NaCl, and you are going to heat it with H2SO4, and this is concentrated. Okay, concentrated H2SO4, and you are going to get NaHSO4 and then HCl. Okay, so once you get this HCl, okay, then we are going to react with ethanol. Okay, this is going to be prepared in situ. Do remember, I cannot use the same reaction to prepare HBr, okay, and then HI. Why? Okay, because this one cannot be done, because sulfuric acid, concentrated sulfuric acid, is a very strong oxidizing agent, where once you get the HBr and HI, they are going to be further reacting, okay, where they are going to give you a mixture of products. Okay, this one you can go and read under group 17. Okay, so we don't want the HBr and HI will not stay like that, okay, because it can be easily broken. Now, write the equation and condition for the reaction of propanol with sulfur dichloride oxide. Okay, so propanol, okay, so same propanol C3H7OH react with SOCl2, heated under reflux, okay, heated under reflux, and then you are going to get, this is substitution reaction, yeah. So you substitute the OH, so quite easy when you want to write down the equation. So you just put the Cl over there. They are going to give you SO2, and then you are going to get HCl. Okay, so you are going to get this thing, yeah. So everything is going to be balanced as well. Okay, do remember these two are gases. Okay, so what happens if they ask you what is the advantage of using reaction in question 6? These two gases, they will evaporate. They will actually just go out to the environment, leaving just the chloropropane over here, which we want. We do not need to struggle to distill them to separate from another compound. So it means the advantage is easier for collection. Okay, easier for collection because no need to distill, as HCl and SO2 are gases, and they will be removed from the vessel. Okay, now write the equation and condition for the preparation of chloropropane using propanol. So same, okay, C3H7OH. I'm going to react with PCl5. Do remember, PCl5 is the one that we need to use room temperature only. No need to heat up because it's very reactive. Okay, it can be broken down into PCl3 and Cl2. We don't want to heat them up. Okay, so you are going to get similar. It's going to be substitution. The OH is going to be replaced by Cl. And then now you are going to get OH is out. One of the Cl is went over there. So you have PCl4. So how do I join them together? Okay, you are going to get you are going to get HCl. Okay, so this H and this Cl, okay, you will be using up. So you have PO and then Cl got 3. So you just put POCl3. Okay, so POCl3. Now, what is the observation in the reaction? So this one is the only gas that is going to be removed. So it's going to be steamy white fume. And this steamy white fume will be used as a good indicator to identify alcohol. Okay, so if you are doing, if you want to test for alcohol, we tend to use PCl5 because you do not need to heat it up, just mix. You see steamy white fumes, you can confirm it's going to be alcohol. Now, describe methods and write equations for the preparation of bromoalkanes and iodoalkanes using a named alcohol. Now, do remember bromoalkanes and iodoalkanes, they are very limited method. Okay, so only one method in your syllabus. Okay, so they are going to be reacting with either PBr3 or PI3, and then they are going to be prepared in situ. So how they are prepared in situ? Okay, so you prepare them, okay, using phosphorus with Br2, you are going to get PBr3. Phosphorus with I2, you are going to get PI3. Okay, how to balance this equation? Just put 2 there, okay, and then you put 3 over there, okay, and you have 2 over here. So once you have this thing over there, so you just write down, okay, the reaction between, let's say, for example, a named alcohol. Okay, for example, I want to react with methanol, for example. So CH3OH, when I react with PBr3, so it's done in situ, yeah. So in situ, heated, okay, heated under reflux, okay, heated under reflux. Named alcohol is going to be methanol. So what do I get? Okay, same. Okay, it's going to be substitution. Okay, take out the OH. The Br will come over here. Okay, so OH is out. Okay, Br went in. So I have PBr2. So how do I join them together over here? So here is going to be, you no need to worry to balance this. Okay, because okay, if you have 3 Br over here, I need to put 3 over there. Okay, 3. And then if I have 3, I put this one 3. Okay, so what is left? Okay, there is no Br, so you are going to get H3PO3. Okay, this one you can actually learn how to balance. Okay, so you are going to get 1P, so 1P is balanced. Okay, 3H, okay, 3H. And because of this, and then O3, everything is going to be balanced. Okay, so this is going to be, you can write down for the another one. Okay, if you are using PI3, so you will get 3CH3I plus H3PO3 also. Now, 11. Okay, write the equation between the ethanol and sodium hydroxide. No need to worry so much. Okay, you do not need to even write the equation because no reaction. Okay, do remember alcohol, they will react with sodium, but alcohol is not acidic enough to react with sodium hydroxide. Okay, so only thing that will react with sodium hydroxide, I think in this chapter, is going to be your ester if you are doing hydrolysis. Okay, and another one is going to be your carboxylic acid because it's a weak acid. Okay, but alcohol, okay, they are not going to react with sodium hydroxide. Now watch the video. I think if you watch the video on ester, okay, there are 3 important concepts that you need to learn. One is going to be esterification. How do you do the esterification? So ester you get from carboxylic acid, you react with alcohol, and then they are going to give you ester and water. And do remember this reaction is reversible and you need to heat under reflux and you use the concentrated sulfuric acid. Okay, now another concept that you need to know is if you can form ester, you can break down the ester. So we have what we call as hydrolysis. Now this hydrolysis, because it's a reversible reaction, you can use the same concept. Okay, like whenever you have ester, okay, it's going to react with water. Reversible is actually kind of the same equation over here. Reversible to give you carboxylic acid plus alcohol. Again, heat under reflux. Okay, and then you use concentrated H2SO4. Still the same. Okay, you can break it down. Now, another reaction is going to be, this is going to be acid hydrolysis. Another reaction is going to be ester. When they react with sodium hydroxide, we call it a basic hydrolysis. Okay, but the difference here is it's not going to be reversible. They are going to be completion. It will go into completion. Now, this reaction, okay, when they go into completion, instead of giving carboxylic acid alone and alcohol, do remember carboxylic acid, they can react with the sodium hydroxide. So they will give you the carboxylic acid salt instead of just carboxylic acid. Okay, so the salt of carboxylic acid will be formed. Okay, so that is going to be another one more thing you need to remember for this. Now, next, write the equation for the reaction of propan-2-ol with concentrated sulfuric acid at 170 degrees. Now, this is going to be dehydration. Okay, so propan-2-ol. Okay, so this is going to be propan-2-ol. So when you do dehydration, so this one is going to be removed. So if I write down C3H7OH, okay, when I do dehydration, okay, I am going to get C double bond C. So it's going to be propene. So propene is C3H6, okay, and then H2O. Next, suggest 2 other catalysts that can be used. Okay, if you have used concentrated sulfuric acid, you can use concentrated phosphoric acid at 170 degrees Celsius, or you can use hot Al2O3, aluminium oxide. Now, number 15. Write the equation using O, okay, for the following oxidation reaction. Now, do remember the difference between this distill immediately and heated under reflux and distill. So basically, they are heated under reflux and distill immediately. So if it is distilled immediately, it means that, okay, both of these propanol, okay, they are primary alcohol. And you know that primary alcohol, when we oxidize, they are going to give you aldehyde. And after that, further oxidation will give you carboxylic acid. Now, when you are distilling them immediately, you do not change them into carboxylic acid. So that's the difference over here. So I'm going to write down, okay, propanol change into aldehyde, and this one is going to be propanol, and it is going to change into carboxylic acid. So I'll just write down C3H7OH. Okay, when I have, okay, this one is going to be propanol. Yeah, so OH. If I put OH, and you see when I oxidize, okay, what will happen? The O will come here. Okay, one of the O will come over there, and then what happens? Okay, the bond, okay, will be broken. So you have this. So you are going to get what we call as C3. Okay, so hold on, yeah, I will write down. Here is going to be 5 hydrogen. So I'll just put C2H5, and then CHO. That's aldehyde. Okay, and then you are going to get water. Okay, now next is going to be, after you get that aldehyde, okay, this one, you get the aldehyde. What is going to happen next? Further oxidation, you get another O, and then they are going to oxidize to give you carboxylic acid. So since we are starting from C3H7OH here, you just need to put 2 O, 1 O earlier, and then another O. Okay, so you are going to get C2H5, COOH, and then plus H2O. Okay, just equation wise only. Yeah, butan-2-ol. Okay, butan-2-ol is going to be okay, this is going to be OH here. Okay, I know what's going to happen. It's going to be just put the O, 1 O. And then this one will be broken. So you have H2O. So only one. So I'll just put C4H9OH plus O. You are going to get C3H. Okay, 1, 2, 3, 4, 5, 6, 7. Hold on, yeah. I just write down. I'm going to get this. Okay. So I'll just put C2H5, CO, CH3, and then plus H2O. Okay, I'm going to get ketone. And then, okay, 1 more minute left. Okay, this is, if you find out, this is going to be tertiary alcohol. Tertiary alcohol, no oxidation. suggest the condition and the two regions that can be used, okay, for oxidation. KMnO4, K2Cr2O7, acidified, okay, and then they must be heated under reflux. And then what is going to be the positive reaction? Yeah. So here, this is going to be purple will become colorless. And this one is going to be orange will become green. And write the equation and conditions for converting chloroethane to propane nitrile. Okay, this one is your previous chapter. So it's going to be chloroethane is going to be, you have CH3. Okay, and then you I'll just put it down here as CH3 CH2Cl, and then I'm going to react with KCN ethanolic, and I am going to get CH3 CH2CN and then KCl. Okay, these are the conditions, and do not forget it must be heated under reflux. And then write the equations and condition for converting this propane nitrile to carboxylic acid. Okay, so this one is going to be, just put CH3, CH2CN. You are going to react with dilute HCl. So it's going to be H2O over there. And you are going to get CH3, CH2COOH plus NH4Cl. Okay, please check. Okay. Now, the carboxylic acid obtained can be also changed into alcohol. Write the equation. Okay, so this one is going to be carboxylic acid. You do the reduction. Okay, you are going to reduce them using LiAlH4 in dry ether. Do remember why we use dry ether. We don't want water because LiAlH4, they are very reactive. So you don't go and heat them up also. So it must be done at room temperature. Okay, so we are going to convert this carboxylic acid into alcohol. Okay, so if I just put it over here, easier to see. Okay, so when I put the H, what will happen? Okay, I am going to remove the O. Okay, so O will go out, H will come here, another H will come here, and this O, another two H will join to give you water. So total of 4 H is required. And you are going to get CH3, CH2, CH2OH. And then plus 1 mole of water. Okay, that's it for today. Okay, so I will send this document